Hello, my lovely viewers. Welcome again to Mathematics and I. It is your favorite presenter, Jeff Naino, and today's topic is angles of elevation. Angles of elevation. Now, if this is the first time whereby you have come across this topic, this is all you have to do. Sit, relax, and listen, and I bet you understand perfectly all what I will be teaching today. Now, first of all, what do you understand by the word elevation? Now, the word elevation means when you go up, when you look upward. That is actually elevation. So what do you understand by the word now angles of elevation? Now, angles of elevation are actually formed between horizontal lines of an observer and the line of sight when he or she looks upward to an object. Now, how can I bring that in reality? Let us assume that this is an observer down here, and this is a tree. All right. Now, this is a tree, and then on top of this tree, there was a bed. Let's assume that is the shape of a bed. Now, the observer wants to look at this bed on top of the tree. Now, the observer needs to raise his eyes so he can see the bed on top of the tree. Now, when he does this, he forms a line. Now, this is the line formed. This line formed is actually called the distance between the observer and the object which the observer is observing. And then this line now is the horizontal line of the observer. And then this is actually the height of the tree. So you see, the angle formed here is called the angle of elevation. As you can see clearly, this angle, which is represented by angle theta, is formed between the horizontal line and the line of sight. This is the new line of sight which the observer made in order for him or her to see the object which he's trying to observe. So this is how you can actually form an angle of elevation. You need to look up to something, and then an angle of elevation is formed. Okay, let us make this plain. This is angle 90. Now, this is our angle of elevation, which is theta. Now, if we say here is A, here is B, and here is C. Now, line AB here is referred to as the opposite. Now, it is referred to as the opposite because it is the line facing the angle, which is the angle of elevation. So it means if my angle is at point A, it means my opposite becomes line BC. Now, line BC here, which is the horizontal line, is referred to as the adjacent. And lastly, line AC is referred to as the hypotenuse. Now, these are the names of the three sides of this right angle triangle: the opposite, the hypotenuse, and the adjacent. Now, for you to be able to solve problems under angles of elevation, you need to understand the basic trigonometry ratios, which are so, ka, twa. All right. Now, so represents sin theta is equal to O here represents opposite over H represents hypotenuse. And then ka, C here represents cos theta is equal to A here represents adjacent over hypotenuse. And lastly, tau, T here represents tan theta is equal to O again represents opposite over adjacent. Now, with the help of this basic trigonometry ratio, which is the sine, cos, and tan, we will be able to solve problems on angles of elevation. Now, sometimes the angle could be special angles or could also be not special angles. Now, when we say special angles, it simply means angles that we don't really need calculator to get their values. Angles like 30 degrees, 45 degrees, 60 degrees, 90 degrees, so on and so forth. Now, these angles don't really need a calculator for us to get their values. While other times, the values of the angle theta can be not a special angles. So, for example, 50, for example, 60 point something, those are not special angles. So, we need a calculator to get their values, or the use of a 4-figure table. So now, with the help of this explanation, let us actually see how we can solve problems on angles of elevation. We are going to be solving two questions. And in our next video, we will see how we can give other questions that is much more difficult than this one. All right, now without wasting time, let's see. Now, don't forget, if this is the first time joining us, you're welcome to our channel. We try our best to see how we can help students understand mathematics in a better way. So if you are just here for the first time, please don't forget to subscribe, and also don't forget to share our videos. Now, question number 1 says, the angle of elevation of the top of a tower from a point on the ground, which is 36 meters away from the foot of the tower, is 30 degrees. Calculate the height of the tower. Now, first of all, we already know that this question is an elevation question because it was clearly stated that what's it called? The angle of elevation. It was clearly stated, so you don't need to be confused. Now, because they mentioned angles of elevation, let us give a diagram. This is angle 90, and this is our angle of elevation. But in the question, the angle of elevation was given as 30 degrees. So it means our theta here is 30 degrees. Okay, and then we were told that the angle of elevation of the top of a tower from a point on the ground, which is 36 meters away from the foot of the tower. Now, class, this line here is the tower, the height of the tower. Now, this place here is referred to as the top of the tower, and this place here is referred to as the foot of the tower. Now, the question said that the distance between the angle of elevation and the foot of the tower. So it means that this is the line that is actually given, and we were told that it is 36 meters. If the question said the distance between the observer and the top of the tower, it means this place automatically becomes the 36 meters. All right, so now without wasting time, we are told to calculate the height of the tower. So this is the height of the tower. So let us say x meters. The height of the towers. So it means that here, what we are simply told to calculate for is the height and not the what? The hypotenuse. So without wasting time, what do we do? Now here, the use of Pythagoras theorem will not work. Why? Pythagoras theorem is only applied when you are told to look for a side of a right angle triangle when the other two sides are given, the values are given. But if you notice, we are told to look for x, but the hypotenuse was not also given. It is only the adjacent that was given. So it means there is no way we can apply Pythagoras theorem. So what should we do? This is where you need to apply your SOH-CAH-TOA. Now, it is either we apply SO or CAH or TOA. You can use the three at once. Now, how do you know which to make use of? How do you know if it is SO you are using, or if it is CAH, or if it is TOA? Now, this is what you do. If you take a look at the shape given, nothing was written on the hypotenuse. So it means SO, CAH, TOA. Now, because nothing was written on the hypotenuse, you will check between SO, CAH, and TOA, which one does not carry hypotenuse. Now, SO carries hypotenuse. We are not going to use that. CAH carries hypotenuse. We are not going to use that. But TOA does not carry hypotenuse. What does that mean? We are going to be using TOA to solve this question because TOA does not have hypotenuse in it. So don't forget we said from the beginning of the class that TOA simply means tan theta is equal to opposite over adjacent. Okay, now theta given here is 30 degrees. So what do? Tan 30 degrees is equal to, now opposite here now is our height, which is x. So here becomes x over, now adjacent is 36. Okay, now without wasting time, here becomes tan 30. Now 30 degrees is a special angle. 30 degrees is a what? A special angle. And what is tan 30 degrees? Tan 30 degrees is 1 over root 3. So here becomes 1 over root 3 is equal to x over 36. Now what do? We have to cross multiply. Now x multiplies root 3 to give us x root 3. And 36 multiply 1 to give us 36. Of course, we are told to look for the height, which is x. So for us to get the value of x, we need to make sure x is the subject of the formula. And for us to do that, we divide both sides by root 3. Now, when root 3 cancels out root 3, what do I have left here? We have x left here. Now, 36 over root 3 can be rationalized. Now, why are we rationalizing? Because of the root sign at the denominator. So here becomes, how do you rationalize? You use your denominator to multiply the numerator and the denominator. So here becomes 36 over root 3 times root 3 over root 3. You use the denominator, which carries the root sign, to multiply the numerator and the denominator as well. So now, if we multiply out, we have this. X is equal to, now 36 times root 3 gives us 36 root 3 over, now root 3 times root 3 gives us 3. Now the question is, how is root 3 times root 3? 3. It is simple. Root 3 times root 3 is supposed to give us root 9. But the square root of 9 is 3. So without wasting time, a number of a root times the same number of the root gives us the number. So it simply means root 100 times root 100 is 100. Root 20 times root 20 is 20. Root 1 times root 1 is 1. You see the logic? So root 3 times root 3 is 3. Now 36 can be divided by 3. Now if 3 should cancel 36, x becomes 12 root 3 meter. That becomes the value of x, which is the height of the tower. So the answer to question number 1 is 12 root 3 meters. Now, like I said, we are going to be treating two questions for today. Okay, 2 questions. And I hope you understood how question 1 was actually solved. Okay, let us go to question number 2. All right, question number 2 says the angle of elevation of the top of a cliff. Now again, the angle of elevation. So we clearly know here that this question is also an elevation question. So let's just draw this down. Now, they said the angle of elevation of the top of a cliff 15 meters high. Now, if this is the cliff, now we were told the height of the cliff is 15 meters. Okay, now 15 meters high from a landmark is 60 degrees. So what does that mean? It means our angle of elevation is 60 degrees. Okay, how far is the landmark from the foot of the cliff? How far is the landmark from the foot of the cliff? Leave your answer in short form. Leave your answer in short form. Now, remember we said this is the foot and this is the top. So it means we are looking for here. Let here be x meters. This is the foot. If they should say how far is the cliff from the top of the cliff, how far is it from the top of the cliff? It means we are going to be looking for the hypotenuse. So this is the foot and this is the top. Now, how do we solve problem like this? Again, 60 degrees is special angles. So the first question is, are we applying so, are we applying car, or are we applying toile? Let us see. Again, we are going to apply what? Tan. Because why? There is no hypotenuse given. So now, tan theta, which says opposite over adjacent, Okay, now theta now is 60 degrees. So we have tan 60 degrees is equal to, now the opposite now is 15 over adjacent is x. Again, tan 60 is root 3 over 1, which is root 3. So here becomes root 3 is equal to 15 over x. Are you with me? Now, what do we do? Base root 3 over 1 and cross multiply. If we cross multiply, x times root 3 gives us x root 3, and 15 times 1 gives us 15. Again, we need to make sure x stands alone. And for us to do that, we need to divide both sides by root 3. So when root 3 comes over root 3, what do I have left? X. Class, 15 over root 3 should be rationalized because of the root sign at the denominator. If the root sign is at the numerator, there is no problem. But when it is at the denominator, you need to rationalize. Now, how did I see rationalize? The denominator, which carries the root sign, multiplies the numerator and the denominator. So here becomes 15 over root 3 times root 3 over root 3. Are you with me? So here becomes x is equal to 15 multiplied by root 3 gives us 15 root 3 over root 3 times root 3 gives us 3. I explained that in the previous example. And we all know that 15 can be divided by 3. But please, never use 3 to divide 3. Never. Because why? This 3 is inside the root. So only numbers inside the root can divide a number inside the root. But 15 and 3, they are no roots, so they can be divided. So 15 divided by 3 gives us 5. So therefore, x is equal to 5 root 3 meters, which is actually the distance between the foot and what is observing. So you see how simple that we can actually solve problems on angles of elevation, simply understanding the fact of the basic trigonometry ratios and also understanding the fact of special angles. So class, we have come to the end of today's video, and I hope you've learned something new. If you have other questions, you can ask, leave in our comment section. And please, if you understood, also leave a comment in the comment section. If this is the first time joining us, don't forget to subscribe. Till we meet again in our next class, keep on watching Mathematics and I. Bye for now.